Hello friends, today we will see large signal behavior of diff pair. So, okay, so we will start with large signal behavior of CMOS MOSFET diff pair. Okay, so here let's consider differential pair. Let's consider differential pair. Okay. Okay. Now, so this is our differential pair, and this is say IT. So this is VCM plus V in by 2. This is VCM plus V in by 2. Sorry, this is minus V in by 2. So this is M1, this is M2, this is ID1, this is ID2. So now say overdrive voltage V on is VGS minus VT. Now suppose differential voltage input voltage V in, say this is equals to 0, then if this is 0, if this differential voltage is 0, then ID1 and ID2 both are equal and half of IT. So ID1 equals to ID2 equals to IT by 2, say this is ID. So if ID1 equals to ID2, then ID equals to beta. Beta is say half mu n COX W by L. So I am considering all these terms in this beta, VGS minus VT square. So these devices are in saturation region. So we can write it like a V on square. So this is V on. We are considering V on equals to VGS minus VT. So ID equals to beta V on square. Okay, so this is our initial condition. Now we need to find out how much. This is our first question: how much V in is required for steering full current from M2 to M1. What does this mean? So this means ID1 equals to IT and ID2 equals to 0. So or vice versa. So how much input voltage V in voltage required to do current steering in diff pair? Okay, now we know ID equation. This is our first equation. This is ID equation. If we want to make ID to 0, it means for ID2 equals to 0, we need to make V on equals to 0. Only in that case ID is 0. So it means, so delta V on to change initially, say when id2 equals to it by 2, then it is v on 2, v on is v on 2 for m2, for m2. Now v on 2, delta v on 2 is initial value or final value, which is 0. Say this is new final value minus old value. So this is v on dash minus v on 2. This is final value, this is initial value. So del v on 2 equals to minus v on 2. So it means we need to make v on 2 0. It means we need to take input of gate of m2, take it down or reduced by v on 2 value. So this is change required in v on 2. Now for id1 is changed from, say, id to 2id, because initially it is it by 2, now it is it. So drain current increased by 2 times. So we can write it like this. Initially it is id, which is equals to beta vo1 square. This is initial value of v on 1. Then new value is id, because current is changed from id to 2id, current is doubled, we need von1 dash square. This is our new value. If we divide both, it will give new von1 dash square root of 2 von1. So this is our new von value. Now okay, so delta von1 is new value von1 dash minus von1, which is equals to square root 2 minus 1 von1 initial value. So this is our delta von1 change required for making it current to be 2 times. Now initially we are considering id1 equals to id2 equals to it by 2. So it means von1 equals to von2, both are equal. Say this is von, this is initially we are having. Okay, so V in differential voltage required is V delta von1. So we can say delta, okay, delta V in. So delta V in or V in required, how we will write this? So this is VG, you can say VG1 minus VG2. So this is delta V in or differential voltage. So source is common, so we can write it like this, VGS1 minus VGS2. If we apply, say, okay, if we write it like this, so this is, say, some DC VCM plus V in by 2, this is minus Vn by 2 VCM minus. So we can write like this, this is this gate voltage minus this, or we can write it like, if we apply